Hello all, welcome back once again. Today we are going to talk about another Google vulnerability which is reported in Gmail, and the vulnerability is about cross-site scripting, and it was identified in 2018, and I'm sure it's pretty old, but still it's good for learning purpose. So I just chose this issue and try to understand it. I would like to share with you and what is the details and what are all the different steps this researcher has done. And this vulnerability, rewarded around $5,000, I think. Yeah, so let's talk about the vulnerability now. So I would like to have a start with a quick question. So what if I told you a Gmail loads hidden pages inside it? And that behavior once led to a serious security bug, actually. So I would like to just show you, or first I would like to give you a quick introduction about Gmail. So Gmail is a modern web application, as everyone know, and it's a single page application, which means um, you can understand that instead of loading everything at once, Gmail dynamically load different parts of the app using the JavaScript, basically. So that's what it's a dynamic application, as I said. So let's see what that means basically. So I would like to show the Gmail and what are all the different iframes which is basically loaded inside. So I would like to show you a quick demo. So I'll open a Gmail and then I will just click the inspect, and you can see here the page. Now I'm going to do a control F and search iframe, and yeah, here and there. So you can see around different iframes are loaded here. So first this one, yeah, and second this one. So now you can see iframe which is loaded for ogs.google.com, and if you go to the next one you can see contacts.google.com, and then you can see other attributes and id. This is one of the important factor that you can just note these down, and the name, id, these are all some important things that we need to remember. And then you can see different other iframes. So this is a main understanding how different iframes are loaded and how it is communicating with mail.google.com. So here we need to talk about a quick definition of iframe. So iframe is basically a web page inside another web page. It's a quick definition probably. And so as you see, Gmail loads something, different iframes internally with the different domains of google.com. So that's how the attacker has actually identified this particular vulnerability. And you can see from his technical explanation, the basis of this vulnerability is that mail.google.com loads an iframe at hangouts.google.com named with that particular frame ID, and then how it is communicating, how hangout iframe is communicating to the mail.google.com with URL, and how the mail.google.com loads that URL in another iframe. So that's the essence of this vulnerability. As we see now, ogs.google.com and how the contacts.google.com is loading. Similarly, when attacker or this researcher is doing the research, he observed that hangouts.google.com is actually loading under the iframe. So that's what he's talking about. So now we need to understand how these hidden frames, iframes, are communicating with each other. Not with each other, I would say, how iframes are communicating with the inside the Gmail. So that's where you need to understand the post message concept basically. So this post messages are very important to understand here. So for that, I would like to show a quick demo in this case. So let's go to the demo. I have created a couple of HTML files. I would like to show both first. So now we can see that attacker.html is receiving the input. In this case, the data is nothing but hello from attacker, which is loaded based on the post message which is present. So that's a simple example to show how data is communicating between iframes basically. So just to show the content of the HTML, I would like to open that with notepad here, and now we can see that I have embedded the victim.html and the content window post message hello from the attacker basically. So this is a quick example to show the iframe communication, but the problem here is in this example, just imagine instead of hello from attacker, the researcher has given a JavaScript like this. So what happens is Gmail unknowingly trusting this messages and loading this particular data. In this place, it's not a data, I would say it's a payload of cross-site scripting, and it is loaded in the Gmail. So that is the exact problem was identified by this researcher. And also you can see the asterisk symbol, which means it is trusting every domain which is communicating in this framework, like how it is communicating using iframe of ogs.google.com, right? Something similarly, any external domain which is trying to communicate with gmail.com, it is trusting blindly. So it's a problem of Gmail basically. So that's what the researcher has identified here. So the attack scenario is very simple here. So in this case, right, I'll just show like this. So I'm opening Gmail. So let's assume this is a Gmail window, and attacker has passed a link to a victim. That attacker controlled domain is also opened here, and that particular test website, this malicious iframe message or which is intended pass the message to gmail.com. So Gmail blindly trusting the attacker's domain, in this case like test.com or something, which is trusting its message and loading in the Gmail website. So that's the main problem of it. And also there are some challenges where the attacker has faced here. Basically this is a the defending mechanism of this CSP. Google had a protection called content security policy. That's the reason this particular scenario was not working completely. So that is also something attacker has mentioned. I mean, in this researcher has mentioned it. So the line item here is, yeah, here you can see that that means that any window frame can send arbitrary JavaScript URL by post message to google.com to pass the execute XSS. So that's what we have seen now. So now this is blocked by CSP and the script source nonce and frame source. However, this is not blocked by Edge or IE11. Anyway, he's also interested to see how CSP is actually protecting, and he has done some research on it. But yeah, that's fine. So he had a challenge on executing the payload on Chrome and other browsers, but he was successfully executed in the Edge and IE11. That's something interesting, and that was he reported. So, and one more problem he has identified is Gmail also tried to have a secure communication using a random channel ID, which means any iframe which is communicating with mail.google.com, it should be secured. So to establish a secure connection, every iframe actually is having a unique ID. So that unique ID was generated by the a method called math.random. So this particular value is not a secure way of generating that iframe ID, I would say. So Gmail was kind of using the math.random. So attacker can try to guess it and predict the value once he understood how the math.random is giving the values. Is it like a sequentially, or is it, he needs to understand the logic, right? So that's where he suggested test math.random on its domain to learn how that values are generated. The first value, based on that, how it is generating the value, and the second one is predict the next state, and then the open like google.com, I mean mail.google.com window, and then how he predicted that value. So some steps he has given it, but he has not achieved, I think. That's what my understanding in this context here. And then he has given another way, I think, but yeah, it's about how he predicted that value, I would say. So with that, I would like to kind of put a summary here. So this vulnerability happened because a Gmail trusting messages from any website. Okay, that's a problem one. And second one is it did not validate the URL. URL in the sense, in the post message, what is the URL that is actually passed? In this case, it's a star. So first one is data, and second one is host. Asterisk means any external website can communicate with the Gmail. So that is another problem. And the next problem is it is using the math.random to generate the unique ID of the iframes, and then it relied too much on browser protection. So it is not the case, should be, but yeah, this is the scenario where this researcher has identified and reported this issue. But as a takeaway, as a bug bounty, in our bug bounty journey, how can we utilize it? So we need to understand how post messages are used first, and second thing is how the data is getting validated, how data and domain is validated. So this too should be properly tested, I would say. And also finally, if you think, if you found this kind of interesting vulnerability, I would please drop in the comment. Probably if you find this video is helpful for you, share with your friends, and follow the space for more such bug bounty reports and how we can understand in a simple way. And thank you for watching, and have a good day.